Welcome to DEEPLIZARD. My name's Chris. In this episode, we're going to see how we can implement BatchNorm in our convolutional neural network using PyTorch. Alright, so I want to implement BatchNorm in the neural network that we've been using throughout this course. Now, if you saw, or if you're following the course and you saw the last couple of videos, they're kind of prerequisites to this. So the 2 videos ago, we did data normalization, and we saw that in order to normalize our data before passing it to the network, that we need to first calculate the standard deviation, and then we calculate, or first we calculate the mean, then we calculate the standard deviation, and this allows us to normalize our data set using those 2 values and a process known as standardization. This is where we calculate a z-value or a z-score by taking each pixel and subtracting the mean from it, and then taking that result and dividing by the standard deviation. So at the end of the video on normalization, I mentioned that the standardization process that we went through to normalize our data as input is also the same process that's used in BatchNorm, where we normalize not the data that's coming in or the input data, but we normalize the activations after a particular layer. So what the idea is that we want to normalize the data coming from one layer. That way it's normalized when it goes into the next layer. So those processes are very similar. So I'm here in the BatchNorm paper where when BatchNorm was created as a method, this is a particular paper for that. And I just want to show you the calculation that they cite, which is the calculation that we implemented before when we normalized our data using standardization. So they have a little kind of sequence of formulas here. The first one is calculating the mean. And so what we can see here, this is what we did. The sum of every pixel divided by the total number of pixels. That gives you the mean. And they're calling this mu sub b or beta. I think that's looks like a b or a beta, but mu sub b. And we take that and we use that in the calculation of what they're calling it the variance. I called this the mean squared error. So what we do is we sum the square of the difference between each pixel value and the mean that was calculated before. And then we divide that all by the total number of pixels. Then finally, what we end up with is what they're calling the normalize. And this is the value x for each pixel x, and we subtract the mean, and then we divide by, this is the standard deviation. And then the difference between the normalization that we saw before and BatchNorm is that there's also these parameters. So there's scale and shift parameters, and these are learnable parameters that exist inside a BatchNorm layer. So if you want to learn more about these particular parameters and the BatchNorm process, be sure to see the BatchNorm video in the Deep Learning Fundamentals course, where we've created a dedicated video that goes into discussion of that. In this video, we're going to focus on getting BatchNorm added to our convolutional neural network that we've been working with throughout this course. So let's do that now. So as we've been doing each time we kind of create new variations in our process, we are testing the previous version of our network or whatever parameters we have set with the new version. So in this case, I want to create 2 networks, that one with the old way, and then the second one I want it to have BatchNorm added, and then we'll run both of these through the training process and see what the difference is. All right, so what we're going to be doing here, if you haven't seen the previous video, we are no longer using the class definition of our network. We're going to be using the sequential way of defining our network. So we discussed everything about how to use the sequential class to build models rapidly and on the fly in the last video of the course. So now we're going to use the sequential module to do just that, So we can test two variations of our network, one with BatchNorm and one without. All right, so let's just take a quick look at our network. This network is going to be defined sequentially. The first layer is a conf layer, then we have a ReLU, then we have a max pool, then we have our second conf layer, another ReLU, a max pool. Then we're going to flatten the output coming from the last kind of conv block with a max pool. And then we're starting the flatten operation. We're going to start at the first dimension. And this is because we don't want to flatten our batch. We want to flatten each image within the batch. So if our batch layer or our batch axis is here, then we're going to flatten every image in the batch. But we won't change our batch size. And that's what this start dims dim function indicates. Then we have a linear layer, followed by a ReLU, followed by another linear, followed by a ReLU, and then finally our output layer, which is going to output 10 predictions because we're using the fashion MNIST dataset that has 10 prediction classes. So let's run this and initialize this network. All right, and then actually something that I noticed was that we should, what in the world? All right, something that I noticed is that we should set the seed. So I'm going to do torch.manual seed, and we'll go with 50. That's just arbitrary. What this is going to do is make sure that the weights that are created randomly for both of these networks should be the same. I think it'll still work even though these have additional. This one's going to have BatchNorm. I think the weights should still be the same. But either way, this won't hurt. What this is going to do is make sure that the random numbers that are generated for the weights are going to be the same. So then down here for our second network, which I've already ran this cell, but the difference is that we're adding BatchNorm. So we're adding BatchNorm here, and then we're adding BatchNorm down here. So we're going to add one BatchNorm right after the first conf layer. So when our data comes in, it's normalized. And so it's going to hit the first conf layer as normalized data. And then it's going to be transformed through this conf, ReLU, max pool. So then we're going to normalize it again using BatchNorm. And so at this point, this is how we use BatchNorm. All we do is we access the BatchNorm 2D because we're dealing with images. And we just say, so notice the 2D there. And then we say, the only thing that we need to say here is how many input features are coming in. So the number of input features to a 2D BatchNorm is going to be the number of out features or out channels in this case, which are going to be 6 coming from the conf layer. So we have 6 in features coming in to this BatchNorm layer. And so what that's going to do is normalize the data, and then those 6 normalized channels are going to come out and come into this conf layer as normalized data. And then those two, the scale and scale and shift parameters are also going to be inside the BatchNorm layer, and they're going to be being updated throughout the learning process. So we do our BatchNorm, then we do our conf, ReLU, max pool, then we're ready to flatten, and then we can do a linear layer, and then a ReLU, and then we can do our other BatchNorm. So it's kind of like you can do BatchNorm after every single layer, or you can kind of sprinkle it throughout. So in this case, we're going to sprinkle it throughout. If you want to try it, adding more BatchNorm into the network, then give it a shot. But for now, we're just going to add in 2 places. So then here, this is a 1D because we're dealing with one-dimensional tensors at this point because we've flattened out our channels. And we're going to pass in the 120 features that are coming from the previous layer. So that's here. This 120 is going to get passed into here, which then feeds through to the next linear layer. We come in with 120, we come out with 60, and then we go into the output layer, passing those 60 features in, and then we finish up with our 10 predictions. So this has already been ran, the cell, so we're ready to just jump down and start working with this thing, both of these models. All right, so to get set up for training, we're going to create a train set. And let's see, did I want to? Yeah, I did want to go ahead. So we're going to create this train set here. This is a non-normalized train set. The only reason we're doing this is so that we can recalculate our mean and standard deviation values. So that's what we'll do here. If you want to know more about this process, be sure to see the previous episode in this course to create a train set normal. And this is going to be a normalized train set with, because we're going to pass the mean and standard deviation into the normalize function, or the normalize transformation, which we've seen in a past video when we debugged. We saw that basically this normalize transformation all boils down to taking those values there for every pixel in the data set and subtracting the mean and dividing by the standard deviation. So that will happen. Indeed, it will happen. All right, so now as we saw before, to hook into our testing framework that we've built throughout the course, or that we've been developing, we need dictionaries. So here I've got two dictionaries. One dictionary of train sets, which we've already seen this particular dictionary in action, and then we have a new one. So this is cool. I don't know, you might have noticed this in the last episode where when we actually set up the train sets dictionary. Let me know if you came on to this in that episode, but essentially it's this same process is going to allow us to work with networks. So we created a train set dictionary. Well, we can also create same thing, same process with networks. So we can run multiple networks through our testing framework. So here we have network one, which is here. This is just the name of it that we're going to use to access it. And then here's the instance, again, the name and the instance. All right, so let me show you how we actually get this to work. So up here, we set up our run configurations. Now, this allows us to test all different configurations. And if there's just one value, then for every run, then that's just going to be the value that will be used. But if there's more than one value, so say like we wanted to do 2 learning rates, then we could do like 001. And what this would do, it would run every possible combination of runs first with the first learning rate and then with the second learning rate. One of the things about BatchNorm that it allows us to do is to train with larger learning rates. So we could test with a larger learning rate to see the effect, but here we're just going to keep it at 0.1. All right, so down here, something else that's cool is that we can just say, what I want to do is I want to get the keys inside this dictionary, this networks dictionary, and I want to try all those values. So what that means is that we can keep putting networks up here all day long, and then they will be injected into this run, this testing framework. So we have two keys, network 1, network 2, and then now they're going to be made available inside of our runs. So now the only thing we have to do to make this process work is come down here and redefine our network. So before, we just were creating the same network every time, every run we create the same network using our network class. Well, now we have various networks that we're going to try coming from this dictionary. So what happens is we get a run, and then that run comes in and it's going to be the active run or the current run. And that run is going to have an associated network with it. And that network is a name. This name here, one of the names coming from this list. And so depending on what run we're on, we will be using network 1 or network 2. And then we put that network on the target device, which is going to be CUDA for all runs. And that's it. Now we have injected networks, or the ability to test multiple networks into this framework. Cool. All right. So actually, yeah, let's just change that. Let's say no batch norm. And then for this one, we'll call it BatchNorm. Okay, so then that'll make it clear for us in the output. So okay, let me reset that and then run this code. And all right, so we got an error here, and the error is size mismatch. And so I'm gonna go and just look at my network definitions. And something that jumps out to me right away is I see 12 by 4 by 4, then I see 12 by 20 by 20 here. So this needs to be 4. This was left over from an experiment that I was doing before recording. And so we just need to reinitialize the two networks. The training set, we'll just rerun all of this and we'll rerun this code. All right, so we just finished and here are all the results. In order to see these results, I want to go grab this line from a previous, this one here. Didn't want to have to retype this, but basically this is going to sort the results by accuracy. So here, let's do that. So we're going to get the run data from the run manager, and then we're going to sort the values by accuracy and descending. Okay, so basically the kind of what you can see here is that the BatchNorm network had gotten as high by the 20th epoch of 93.7%, and it pretty much smoked the NoBatchNorm network. So the NoBatchNorm network got up to 91%, and that was by epoch 20. So we can see the BatchNorm was already higher than that at epoch 10. So we typically refer to this as much faster convergence. So the model or the network converged on its minimum much faster than when it had BatchNorm versus when it did not have BatchNorm. So this is something that BatchNorm can give us and why it's powerful. Plus, it got us all the way up to 93% after pretty much 94% after 20 epochs. Now, there was one thing that I had to do. I got an error when I first tried to run this. I got two errors. The second one I showed you. The first one I had to go debug, and it was because I changed these names, and these names here are longer than the previous name that I had, and what that did was it caused problems in the program or in the class that in our run manager class. So essentially, it was with the TensorBoard portion of this particular class. I had to when the TensorBoard instance is created, we pass a comment to its constructor, and that comment is used to name the file, the TensorBoard file. And the issue is that it uses all these names to construct its file name, and this particular name made it too long of a file name. And so essentially what I did was I removed that comment because I'm not using TensorBoard anyways. Whenever we did the TensorBoard lessons, I mentioned that TensorBoard is kind of weak in regards to querying the information, and that it would break down at some point as a viable solution to really query all of the information that's possible. And so at this point, we have quite a bit of info here. We're changing networks, and we can really build on top of this test framework quite a bit more. And so really, I'm not going to try to find a solution to the TensorBoard issue. If you want to and you find an issue or find a solution to it, then put your solution in the comments for what could be done there. But I'm not going to do it because I'm not using TensorBoard. I would just basically query this table like we have to just get a bird's eye view of, like, we could do probably, I don't know, thousands, really any number of tests, and then just query through the information. TensorBoard's just not going to do much for us there. So anyway, if you run this code and you get an error, then go up into the run manager and remove the comment from the TensorBoard constructor. And then, so what that'll do is that will, instead of manually setting the file name, TensorBoard will just name the file based on the time and date, I believe. So it's not like you can still go into TensorBoard and look at the run. You're just not going to have all of the run information like in the file name like we had before. So keep that in mind. Now, if you didn't know, we're actually filming this video from Vietnam, and we have another channel called DEEPLIZARD Vlog, where we connect with you guys in a new way, and we document all of our travels. So go over to DEEPLIZARD Vlog on YouTube and check it out. Right now we're in Vietnam. The videos that are coming out on that channel are from when we were previously in Thailand before coming to Vietnam. So the Vietnam videos will come out sometime in the future. But also, if you haven't already, be sure to check out the DEEPLIZARD HIVEMIND, where you can get exclusive perks and rewards. Thanks for contributing to collective intelligence. I'll see you in the next one.